So now that we have studied friction, we can start integrating friction into our problem sets. So you're moving into college, you drag a 230 Newton box across the floor with a force of 50 newtons at 18 degrees. And the coefficient of friction between the floor and the box is 0.19. So remember that the coefficient of friction tells you how smooth or rough the surfaces are, and it is generally under 1. So the closer to 0 it is, the smoother it is. The closer to 1 it is, the rougher it is. It doesn't mean that it can't be above 1. It just means above 1 would be really, 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 really friction, like maybe two heavy pieces of sandpaper rubbing against each other. So if I draw my force diagram here, so I have my box, and I have the box has a certain weight, which I'm going to pull down here. So the force of gravity is 231 newtons. Remember that from the weight, I also always have to know the mass. And in order to find the mass, I'm going to divide the 231 by 9.8. And that is going to give me a mass of 23.6 kilograms. So the next thing I would look at then is I would say, hey, I am pulling with this much force. So I have a force going this way that is 50 newtons, and I can break that 50 newtons up into an x component, which is going to be 50 times the cosine of the angle, 18, and I'm going to break it up into a y component, which will be 50 times the sine of 18. And when we put those into our calculator, we end up getting a value for the y of 15.5 and a value for the x of 47.6. Now, on the AP test, they would not want you to leave the original vector there. They either want you to draw the original vector or the components, but not both. So I'm going to erase that one just to get rid of it and say that it is not there anymore because I replaced it with the x's and the y's. I would look at the rest of this and say, hey, there's another force. The box isn't moving up or down at all, which means that there has to be the force of the ground pushing up, and that is going to be our normal force. And together, the normal and the y value have to cancel out with gravity. So if I want to find the normal force, I'm going to take the gravity value, 231, and subtract the y value to get that normal force. And I end up with a value of 215.5 newtons. Okay, then I have one last force that I haven't put on here yet, and that is the force of friction. Remember that the friction is going to be acting against us, and that force is equal to mu times the normal force. And that's why we always have to find the normal force in these problems. So I can say then the coefficient of friction, which is the 0.19, times the normal force, which was the 215.5 newtons, gives me a force of friction value of 40.9 newtons. So now I have all of the forces. They all have arrowheads. They are all labeled force of friction, force normal, force y, force x, force of gravity, and they also have number values. Now that I have all those values, we can start doing the problem where we would say, hey, is this moving? It's not moving up or down at all. We already established that, so those forces cancel out. So the only motion is going to be in the side-to-side direction, which means I can do an F equals ma in the x direction. It's moving to the right, so I can say that that x value is positive, minus the force of friction, or plus a negative friction, because that's going to the right, equals m times a. And then I can plug numbers in. 47.6 minus 40.9 equals the mass. That's why we had to find the mass, 23.6 times a. Solving for a, we end up with a value of 0.284 meters per second squared. And that would be the acceleration of your block. Now from there, what we could do is we could take that one step further and tie it back into kinematics. And maybe how far did it go in a certain amount of time, or how fast is it going after a certain distance. So that's just a real quick outline of how to solve some of these friction problems. All that it does, take your ones that are on a flat surface, finding your normal force and using the mu value to get the friction, and then tie the friction in just like we've done on all the other ones. And or the same thing on a hill, where if you're on a hill, you have the normal force of the hill, you can find the force of friction based off of the coefficient and from the normal force of that to solve for what the acceleration is.